G'day everyone, how you going? Today what we're doing is proving the quotient rule. Now, a previous video, I looked at the quotient rule and how to use it, and that's fine for most courses. That's going to do you absolutely fine. There may be a chance that you need to prove it, or maybe need to make some sort of understanding as to why it works. So I kind of wanted to just step through it here a little bit so that you've seen it. That's all it is. Skip on through the video, see it once, go, okay, I'm good with that. If I need it, I can come back and have a look. I've set myself out a little schematic here because I thought I was going to get stuck halfway and forget a step, so I thought a bit of a schematic was going to be good here. This is what we're talking about here. We're finding the derivative of a function or one function divided by another, and that's got to be key. That's when you're using the quotient rule, is one function divided by another. Now, let's just add a little work here. If I had something like x plus 2 divided by, I don't know, x minus 3, that fits that. That's one function divided by another. Okay? But, and students get trapped on this one oftentimes, if I have something like that, that is not a case of the quotient rule. Okay? Because this is not a function. There's no x value in it. There's no function on the bottom line. This, we can basically ignore when we're doing our derivative. Just take the derivative of the top line and carry that one on through, but don't do anything with it. Okay? So this here is an example of a quotient rule question. This is not an example of a quotient rule question. Okay? So if we start with this, two functions, one divided by the other, f and g, using that idea of limiting chord, first principles, really what we're doing this one with the plus h in it, minus this one. Now I haven't got room to put that diagram up, but previous videos I had the line, the 2 points, h on the bottom here, we'd have f of x, and then on the second point, f of x plus h. I'm doing exactly the same thing right here, and then I'm dividing by h. Now really, this is x plus h minus x, but we can cancel the x's out, we don't need them anymore, we realise it's just going to be h on the bottom line. So once I've got that, what I'm now going to do is two things in one really. I'm going to see this h as divide by 1, so it's kind of fraction over fraction. And if I was to bring that fraction up to the top line, I've got to invert it, don't I? Because if I'm going to divide by a fraction, that's the same as multiplying by its inverse. Okay? That's the first step that I've got to do. And the second step, you'll notice here, I've put this part on a common denominator. So because I want a common denominator of g of x plus h and g of x, I've got to multiply that one up to there and that one up to there. So I'm going to end up with f of x plus h times g of x minus that one, f of x times g of x plus h. Now you should be able to see that if I split that up into two fractions, this part here minus this part here, parts of it would cancel out and get me back to here. Okay? It looks a little bit different to the fractions you used to with numbers, but it's the same idea. Now up over here, I've got my little cheat here, and I wrote minus and plus f of x, g of x. So like in our previous one, the product rule, we had to kind of massage and add and subtract something in there to be able to get it to work. So I'm going to write the first part here, f of x plus h times g of x, and then I'm going to write minus f of x times g of x, and then plus f of x times g of x, and then this part here, minus f of x times g of x plus h. Now it's getting pretty long there, but what I'm now going to be able to do, I'm going to be able to rearrange a little bit here. Notice the g of x's are common here, and the f of x's are common there. Okay? So my next step is to bring a few things together. Bring the g of x out front of f of x plus h minus f of x. And now this next step, we've got to be a little careful here. I'm going to take the minus out front. Okay, so of these two terms, I'm going to take a negative out front. And I'm going to take f of x out front. Right? So now that means that this g of x has to be negative to cancel that out. Alright? But I'm going to write it the other way. I'm going to actually write this one, which I can leave as positive because I've already taken the negative out. I'm actually going to write that one first, minus the other one. Okay, if you're unsure, multiply this back into there. You'll notice I get minus f of x, g of x plus h. And this one, the two negatives will cancel, getting me here. So I haven't changed anything, and we're pretty good with that. Now that's all over h, g of x plus h, times, don't need that bracket, g of x. Now, little thing I put over here as well. We've got to kind of think what we're doing here. Right? We've got to think what we're doing here. Look at this second one, g of x plus h. When h tends towards 0, isn't g of x plus h just going to tend towards g of x? Because if h is getting smaller and smaller and smaller, it's getting closer and closer to this as h tends towards 0. So this one here, I can really rewrite that as just g of x. And you'll notice on the bottom line I get g of x squared. There's two of those on the bottom line. So the bottom line here is just going to be g of x, I'll put another bracket around to make it clear, squared. Okay? So I get that there, and then what I do is on the top line, I'm going to set this h here. I actually want to get that back up on the top line. And I can do that because then this part here with this h kind of hidden, taken back up here, can you see how I'd have this divided by h? And isn't that g of x? Now this part here divided by h, isn't that just the derivative of f of x? F of x plus h minus f of x divided by h, isn't that just the derivative of f of x? Go back to our differentiation by first principles. I'll try and kind of isolate it here if we can. That there, that part right there, that's just f dash of x. So I can add that in. Minus f of x. And isn't that in the same way, this h here, which I'm going to divide everything by, and this here, isn't that really just g dash of x? That's really just the derivative of g of x written in that longhand form. So times g dash of x. And then we've got our quotient rule formula. It's the bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom square. So we get to where we think we were going to get to by working our way through here. Yeah?
I'm very confused. Could you like start from the beginning?
I can. Rewatch my video and have another look at it and I'll explain it to you again. Hopefully that one's helped. I wouldn't get too worried about this. I'd just go, yeah, I remember seeing it. Yeah, he did some fancy stuff. He added and subtracted and it all just fell out. If you know that at the moment, you can always go back and have a look at it. It's unlikely to come up in an exam, but I hope this has helped to kind of build your understanding of quotient. Thanks very much, guys. Catch you later.